Today I will talk about a very important topic of atomic structure and some important multiple choice questions on atomic structure chapter. So there are around 70 questions and I will talk about their answers. So these are very important for any competitive exam or any kind of exam having the chemistry paper where atomic structure is a chapter. So let's start. The first question is, a chromium atom in its ground state has a 3d5 4s1 configuration and a copper atom had a 3d10 4s1 configuration. This is because a shell which is half filled or completely filled is particularly, the right answer is strongly exchange stabilized. So we know that for chromium and copper, as they are strongly exchange stabilized configuration they have, so this is why they don't have rather 3d5 4s1 instead of 3d4 4s2. Okay, so this is a very important question. Next comes, a d shell containing 4 unpaired electrons can exchange. The right answer is 6 electrons. Next, based on quantum mechanical theory, the electronic configuration of palladium, whose atomic number is 46, is, the right answer is, it should be 4d10 configuration for palladium. Fourth one is, when a gold sheet is bombarded by a beam of alpha particles, only a few of them get deflected, whereas most go straight, undeflected. This is because, so this is the gold plate experiment by Rutherford regarding that. So this is because a nucleus, option B, a nucleus has a much smaller volume than that of an atom. So that's why most of the particle go straight undeflected. Fifth question is, which of the following statements is incorrect for anode rays? The right answer is option C, the charge by mass ratio of anode rays is constant. So option C is the right answer. Sixth question is, Rutherford's alpha particle scattering experiment led to the conclusion that, and the right answer is, the mass and the positive charge of an atom are concentrated in the nucleus. So this is the right answer, option B. Next, the radius of aluminium 27 by 13 will be, what should be the radius of this aluminium atom? So the right answer is option D, 3.6 into 10 to the power minus 15 meter. So next is, the density of nucleus of an atom is, the right answer is option C, 2.4 into 10 to the power 17 kilogram meter to the power minus 3. The next is, in an X-ray experiment, different metals are used as target. In each case, the frequency of, or the frequency nu of the radiation produced is measured. If Z is the atomic number, which of the following plots will be a straight line? There are 4 options which individually lead to a plot, and which of them will correspond to a straight line? So the right answer is root of the frequency nu against the atomic number Z. That is option C is the right answer. The 10th question is, in Moseley's equation, which was derived from observations made during the bombardment of metal targets with X-rays. So the right answer for this one is B is the independent of, but A depends on the metal. So B is independent of the metal and the A value depends on the metal. So option D is the right answer. 11th one, which of the following reactions led to the discovery of neutron? And the right answer is option C. So beryllium, when reacts with alpha particle or helium, lead to carbon and neutron. So option C is the right answer here. Next comes, let m be the mass of the proton and mn that of a neutron, m1 that of a neon nucleus and m2 that of a calcium nucleus, then which one of the following equation is correct? The right answer is option B, that m1 less than 10 of mass of proton and mass of neutron. So that is the right answer, option B. For question number 13th, that a positronium consists of an electron and a positron orbiting round their common center of mass. Calculate the value of Rydberg constant for this system. So what should be the Rydberg constant for this system? Right answer is option A. What are the average distance and most probable distance of an electron from nucleus in the first orbital of a hydrogen atom, where A0 is the radius of the first Bohr orbit? Okay, so this is the 14th question. The right answer is 1.5 A0 and A0. This is the right answer, option A. For 15th, calculate the mass of a deuterium given that the first line of the Lyman series of hydrogen lies at 82,259.1 centimeter inverse. So what should be the mass of the deuterium? The right answer for this one is option D, 3.34 into 10 to the power minus 27 kilo. Next is the energy of a 700 nanometer photon is, the right answer is option A, 1.77 electron volt. Next, 17th one is a 1 kilowatt radio transmitter operates at a frequency of 880 hertz. How many photons per second does it emit? The right answer for this one is option B, 1.71 into 10 to the power 30. 18th is the ratio of E by M values of a proton and an alpha particle is, what is the ratio of the E by M values for proton and an alpha particle? So for the 18th one, the right answer is option A, 2:1. The ratio is 2:1. 19th is, which of the following pairs have identical values of E by M? So the right answer for this one is option C, deuterium and an alpha particle. So these are having the identical values of E by M ratio. 20th question is, which of the following is an arrangement of increasing value of E by M? So the right answer is option A, neutron less than alpha particle, less than proton, less than electron. So this is the right sequence or the order of increasing value of E by M. So this was the 20th question. So next we will move to the 21st one, which is, which particle among the following will have the smallest de Broglie wavelength, assuming that they have the same velocity? The right answer is an alpha particle, option C. Next is, the velocity of the de Broglie wave is given by. So what is the expression for calculating the velocity of de Broglie wavelength? The right answer is option B, h nu by mc. So option B is the right answer. Then the de Broglie wavelength is related to applied voltage as, the equation is option B, lambda equal to 12.3 by root of the velocity in terms of angstrom. Next comes, find the de Broglie wavelength of a 1 mg grain of sand blown by a 20 meter per second wind. So what should be the wavelength of de Broglie? What should be the de Broglie wavelength of that grain under the sand, grain of sand? The right answer for the 24th question is option A, 3.3 into 10 to the power minus 29 meter. So 25th one is, the momentum of a hydrogen atom is given by. We know that P equal to h nu by c. This is the right equation to represent the momentum of a hydrogen atom. Next, for an electron, the product, that means the product of velocity and principal quantum number, will be independent of which factor? So the right answer is, it will be independent of the principal quantum number. Okay. Next is, assume that the potential energy of a hydrogen atom in its ground state is 0. Then its energy in the first excited state will be. What will be the energy of the first excited state of that particular atom? So the right answer should be 23.8 electron volt. Next is the ratio of E2 minus E1 and E4 minus E3. The energy differences for the hydrogen atom is approximately equal to. The right answer is option B, 15. Next comes the 29th question, that the ionization energy of a hydrogen atom is 13.6 electron volt. We know that the energy of the third lowest electronic level in doubly ionized lithium, whose atomic number is 3, will be the right answer is option C, minus 122.4 electron volt. Option C is the right answer here. The 30th question comes as, what is the most probable distance from the nucleus at which a 2p electron will be found in the hydrogen atom? So what will be the probable distance for that? The right answer will be that it will be 106 picometer. The energy needed to excite a hydrogen atom from its ground state to its third excited state is, answer should be option D, 12.75 electron volt. 32nd question is, the frequency of one of the lines in the Paschen series of hydrogen atom is 2.34 into 10 to the power 14 hertz. The quantum number n2 which causes the transition should be, so what is the level of transition for the Paschen series? We know the Lyman, Balmer, Paschen, bracket fund, those series for hydrogen atom. So for the Paschen series, what will be the n2 value for this one? So the right answer should be the D, that is n2 will be 5. Next is, the line spectra of two elements are not identical because, the right answer is option C, their outermost electrons are at different energy levels. This is the right answer for that. Next comes, the wavelength of the third line of Balmer series for a hydrogen atom is, what is the expression for the wavelength of the third line of Balmer series? The right answer is option B. Next comes the 35th one, in which of the following transitions will the wavelength be minimum? The right answer for this one is option C, that n equal to 3 to n equal to 1. The next question, 36th question, is, in which of the following is the radius of the first orbit minimum? And the right answer for this one is option C, triply ionized beryllium. So for this, the radius of the first orbit minimum. So triply ionized beryllium is the right answer for this one. Next comes, when the electron of a hydrogen atom jumps from n equal to 2 to n equal to 1 state, the number of spectral lines emitted is, what are the number of the spectral lines that will be emitted during that transition or the jump? So for this one, the right answer is option B, that is 6. We will have 6 lines. Next is the quantum number not obtained from Schrödinger wave equation. Which quantum number we don't obtain from Schrödinger's wave equation? The right answer should be the ms, option D. Next question is, if a magnetic field is applied to the electron of a hydrogen atom in the z direction, the z component of the spin angular momentum is given by, so that will be given by the equation D. So equation D is the right answer for that one, plus minus half into h by 2 pi. This will be the spin angular momentum will be equal to that product. Next, the 40th question is, what are the values of the orbital angular momentum of an electron in the orbitals 1s, 3s, 3d and 2p? And we have a sequence for each of the angular momentum for each orbital, and in the 4 options. The right option should be for this 4 is option A, 0, 0, root over 6 h Planck's constant, root over 2 into Planck's constant for 1s, 2, 3s, 3d and 2p respectively. 41st question is, in an excited state, a calcium atom has the electronic configuration 1s2, 2s2, 2p6, 3s2, 3p6, 4s, 3d. What is the angular momentum of this state? So this is the 41st question, and the right answer is option C, root over of 20 into Planck's constant. For next is, for a hydrogen atom, what is the orbital degeneracy of the level that has the energy of this one minus hc r infinity Rydberg constant by 9, where the r infinity is the Rydberg constant of the hydrogen atom. So for the 42nd question, the right answer should be option B, 9. Next, the maximum number of electrons in a subshell is given by the expression. How do we express the maximum number of electrons in a subshell? So this is given by the expression of 4L plus 2. So this is the expression for that. And the total, next is the total number of subshells in nth energy level. So just mind it, the total number of subshell in the nth energy level is, so the right answer is n. Next is, when the value of azimuthal quantum number is 3, the maximum and minimum values of the spin multiplicities are. What should be the minimum and maximum values for spin multiplicities? The right answer is option D, 8 and 2. 46th one is, if the value of principal quantum number is 3, the maximum number of values of magnetic quantum number can have. So if the principal quantum number is 3, how many magnetic quantum numbers we can have from there on? So the right answer should be 9. Okay, that is option C is the right answer. Next is that the correct set of quantum numbers of the unpaired electrons of a chlorine atom is, the right answer is option C. So it can be 3, 1, -1 and plus minus half for the spin quantum number. 48th one is, the Pauli exclusion principle is not applicable to. The options here you can see the electrons, positrons, photons and protons. The right answer should be the photons, that is option C is the right answer. Next, the 4 sets of values of quantum numbers are given here. Which of these does not provide a permissible solution of the wave equation? Which will not be the permissible one? The right answer should be option B, 3, 3, 1 and minus half. So this will not be permitted, where the azimuthal quantum number and principal quantum number will have the same value. 50th question is, which of the following sets of quantum numbers represents the highest energy of an atom? And the right answer is option D, where the principal quantum number is 3, azimuthal quantum number is 2, magnetic quantum number 1 and the spin quantum number is plus half. That will have the highest energy for that particular atom. Next is, the 4 quantum numbers of the valence electron of potassium are. What are the quantum numbers for potassium? The right answer is option B, 4, 0, 0, half. So those are the 4 quantum numbers for potassium. Next is, the following sets of quantum numbers represent 4 electrons in an atom. You can give the quantum numbers here. In this context, which of the following represents the order of increasing energy? So out of these 4 options, here we have this 4 different options here with the increasing energy. So what will be the right answer for that? So option A should be the right answer, that is 4 will have less than 2, then 3 and then 1. So this is the order of increasing order of energy with the 4 given quantum numbers. Next comes the total number of orbitals in a shell with principal quantum number n is. The right answer is option C, n square. 54th is, if m equal to magnetic quantum number and L equal to azimuthal quantum number, then which equation is correct here? The right answer is option C, L equal to m minus 1 by 2, that is m equal to 12 plus 1. 55th question is, which of the following sets of quantum numbers represent the 19th electron of chromium, whose atomic number is 24? So how to assign the 19th electron of chromium? So the right option should be option A. 56th question is, which option gives the values of quantum numbers for the 21st electron of scandium, whose atomic number is 21. So for this one, the right answer should be option B. These are the set of quantum numbers for the 21st electron of scandium, that is the last one at the peripheral shell. Next comes the electronic configuration of Fe3+ is. What is the preferable configuration for Fe3+? The right answer is option C. It will have the configuration, basic configuration of argon and then 3d5 4s0, that is the 3d5 system Fe3+. Next comes the number of unpaired electrons in manganese 4+, whose atomic number is 25. So how many number of unpaired electrons will be there? So the right answer will be option D, 3. Then comes the configuration. Following configuration, argon followed by 3d10 4s2 4p1 is similar to that of. That means which atom this assign? The right answer is it assign the aluminium. Okay. Next comes among the following, or it is similar to that of aluminium. I mean, with the outermost given the electronic configuration, which is to which it is similar. So it will be similar to the aluminium one in the group of aluminium. 60th question is, among the following, the configuration 1s2, 2s2, 2p5, 3s1 is valid for. The right answer is the excited state of neon. Okay, so this is the right answer. 61st question is, after np orbitals are filled, the next orbital filled will be. So which will be the next orbital to be filled? The right answer should be n+1s. Then comes the value of the magnetic moment of a particular ion is 2.83 Bohr magneton. The ion is. So which ion to it refers? The right answer is option B. It refers to nickel 2+. Then there is electronic configurations given. Which of the following violates the Pauli exclusion principle? This is a bit easier one. So option C is the right answer for here. And we come to the 64th one, where the question is, which of the following violates the Aufbau principle? Okay, so the right answer is option D. It violates the Aufbau principle. Next comes the 65th question, which of the following electronic configurations have the highest exchange energy? So the right answer is option D. Then comes the 66th one, that which of the following sets of orbitals is arranged in the correct order of increasing energy? So the right answer for this one is option C, that 4s having less energy than 3d, then 4p, then 4s, 5s, then 4d. So this is the right sequence of or order of increasing energy of the orbitals. So option C is the right answer. Next comes the number of spherical nodes in 3p orbital. So what are the number of spherical nodes in 3p orbital? This is option A is the right answer, that is 1. 68th question is, in which of the following orbitals is there zero probability of finding the electron in the xy plane? So in which of the following the electron having the zero probability to find in the xy plane? The right answer is in the p orbital. Okay, so that is pz. To specify, option D is the right answer here, in the pz orbital. Next is, which of the following electronic configurations have zero spin multiplicity? The right answer for this one is option C, that it will have the zero spin multiplicity. The last question is 70th one. The radial distribution functions for all orbitals is given by. So this is given by the expression of n minus L minus 1. So this is the last question. This was. So thank you for watching my channel TG Chemistry, and I hope the topic and the multiple choice questions and the answers will help you in your exams. And if you like the video, please do subscribe my channel and press the bell icon to get the notification further, to get the videos that I upload in future. Thank you.